We're going to do some trig review today and also some vocab. All right, so a boy flying a kite lets out 300 feet of string, which makes an angle of 38 degrees with the ground. Assuming that the string is straight, how high above the ground is the kite? So if the kite is right here and the string is straight to me, this little dot, the angle that the string is coming out in relation to the ground is 38 degrees, which I'm going to call theta. And I know that the string itself is 300 feet. Okay, so since I have a right triangle and I want to find out the height, then I'm using the opposite side of my angle and the hypotenuse of my angle. So I'm going to use, according to SOHCAHTOA or Trig ratios, I'm using the opposite and the hypotenuse. So this is a sine ratio. So I'm going to end up using the sine of theta is equal to the opposite side over the hypotenuse, which is equal to, well, okay. And so we're going to have the sine of theta is equal, theta is 38 degrees, and the opposite is the height, okay, over, I'm going to put height, over, actually, you know what? I'm going to call that H. We're going to call this opposite and hypotenuse, like that. Okay, so H is the vertical length, and 300 is the length of the hypotenuse. So to get H by itself, we're going to multiply 300 on both sides. So I get the height of the kite is equal to 300 times the sine of 38 degrees. This is the exact value. And then let's get the decimal equivalent. So I'm going to use my calculator, and I'm going to go ahead and make sure my mode is set to degree mode because we haven't done anything in radians yet. So degree, enter, press 300 times the sine of 38 degrees, okay? And I get 184.9698, which rounds to 70. Okay, so this is my rounded value. Okay, let's do another one. All right, so I got my 184.70. You can see that I rounded that value. All right, so a ladder is leaning against a wall and makes an angle of 74 degrees. Okay, it won't stop. If the foot of the ladder is 6.5 feet from the wall, how high on the wall is the ladder? Okay, so I got my wall, and the ladder is leaning against that. Okay, and it says that the ladder makes an angle of 74 degrees with the ground. So this angle, 74 degrees, is equal to theta. Okay, and if the foot of the ladder is 6.5 feet from the wall, so that means that the bottom length is 6.5 feet. So I am going to figure out how high the wall is. So this part, okay. And since I have the opposite side from theta and the adjacent side from theta, according to my trig ratios, the trig ratio that uses the opposite and the adjacent side would be tangent. So I'm going to, tangent of theta is equal to the opposite side over the adjacent side. So I have the tangent of 74 degrees, which is where I'm standing, 74 degrees, or where the base of the ladder is equal to unknown, so the wall over 6.5. Okay, to isolate the length of the wall, we multiply both sides by 6.5. So I get an exact value of 6.5 times the tangent of 74 degrees. And that is about equal to, and we'll go ahead and grab our calculator, 6.5 times the tangent of 74 degrees. Gives me 22.668, and the 6.8 rounds, the 668 rounds to 6.7. And I forgot my units, so feet. Okay, so I should have written feet on the last one. Okay, all right, number 3. A straight road to the top of a hill is 2,500 feet long. And so straight road to the top of a hill and makes an angle of 12 degrees with the horizon. Okay, so that means that this angle here is 12 degrees and the road is equal to 2,500 feet. Okay, so find the height of the hill. So we want to find the height. So this is, do we use sine, cosine, or tangent? And because it's the opposite side versus the hypotenuse, we're going to use the tangent. Or sorry, the sine. The sine of theta is equal to the opposite side over the hypotenuse. Okay, so the sine of 12 degrees is equal to h over 2,500. Multiply both sides by 2,500, or 2,500, and I get the height is equal to 2,500 times the sine of 12 degrees, which is about equal to, I'll use my calculator, 2,500 times the sine of 12 degrees, 519.78. Okay, again, this is our exact value and our rounded. All right, we're going to skip this one, move on to the next one. Oops, sorry. There we go. Okay, so the definitions. I gave you the definitions. We're going to draw an example and then just move on. Okay, so an angle is a shape formed by two rays or two lines at a common point, which is the vertex. So it would be something like this. If I have my vertex and two rays that are line segments pointing in one direction, okay, then I have an angle. So it's an opening, basically, is our angle. We measure our angle in degrees or radians. So this is the vertex. This is ray 1 and ray 2. Okay, the initial side is if one arm of your ray, this one is fixed, so it doesn't move, and the other one swings open, then the fixed side is the initial side. Okay, the arm that rotates, okay, so this guy, the arm that, oops, okay, so this one is the initial. The arm that rotates is your terminal side, the ending arm. Okay, standard position. So on a coordinate plane, so the XY axis, we write our angle as with the vertex at 0, 0, okay? And then the initial side has to be on the x-axis. So these two pieces have to exist, otherwise your angle is not in standard position. So if your angle looks something like this, where your initial side was maybe right there at 45 degrees, and then the terminal side was over here. This is not a standard position. Your standard position has to have a vertex at 0, 0, and an initial side on the positive x-axis. Okay, positive angles. positive angles open, so the terminal side swings in the counterclockwise direction. Okay, so counterclockwise goes this way. Okay, negative angles, they swing in the clockwise position, so this way. Okay, degrees. A degree is denoted by the degree symbol. And if you think about a circle, oh, that was a pretty good circle, then you can split this circle into 360 parts. And so when you do that, we get basically 360 little wedges, okay, along the circle. So each degree denotes 1/360th of the circle. Okay, so there are 90 between from here, from the positive x-axis to the positive y-axis. There's a total of 90 degrees. There are 90 degrees in the second quadrant, 90 degrees in the third quadrant, and 90 degrees in the fourth quadrant, giving us 360 degrees in the whole circle. An acute angle is one that is less than 90 degrees. So an opening of 89 degrees, 89.9 degrees would be an acute angle. In radians, an acute angle would be something that's less than pi over 2, so like fourth pi over 4. An obtuse angle is an angle between 90 degrees and 180 degrees. I can do it better. 90 degrees and 180 degrees. So something like that. It would open, an obtuse angle would open in the second quadrant. Okay, an acute angle opens it to the first quadrant. Okay. A complementary angle is one that there's two angles that add to 90 degrees. So complementary angles could be like, I'll draw them on the coordinate plane. So initial side, the terminal side ends at 30 degrees, and then a complementary angle would be the angle that adds to 90, so the remaining part would be 60 degrees here. Okay. Supplementary angles add to 180 degrees. So something like if we started again with our initial 30-degree angle, and then we added on another angle to make 180, the remaining opening would be 150 degrees. Okay, just two angles that add to 180 degrees. In radians, 180 degrees is equal to pi. Okay. Periodic functions are functions that repeat. So like a sine function that we're going to study looks something like let's get another color. Looks something like this. It periodically repeats itself. So you can see that the pattern continues to repeat itself over and over and over again over the same time interval, okay? Or the same amount of time. A radian is another way that we measure angles. Instead of, if you think about pizza, actually, yeah. Let's draw a slice of pizza right here, okay? Or an angle. A degree is measured by how open the two sides are from each other, okay? It's like the pointy part of the pizza The radians measures the arc length, so the crust. So it measures how long the crust is of the pizza. Okay, it's the arc length of the angle. It also, 1 radian is equal to 1 radius of the circle. 1 radian is equal to however long the radius of your circle is. Okay, there are 2 pi radians in a full circle. So if I draw a full circle all the way around, okay, if I start at 0 degrees and go all the way around, that's 360 degrees, or in radians, that's equal to 2 pi. It's basically the circumference of a circle, okay, 2 pi. All right, a coterminal angle is when 2 angles share the exact same initial and terminal side. Okay, so I'm going to draw myself an angle right here. I'm going to just keep going with this 30-degree angle. So I'm going to start on the x-axis and open up to 30 degrees. Now, a coterminal angle would be if I started on the same initial side of the positive x-axis, but maybe this time instead, I'm going to go all the way around one circle and then end up and then stop my terminal side where the purple angle was. So what I've done is I've gone around 360 degrees plus another 30 degrees, which gives me an angle of 390 degrees. So this green angle is 390 degrees. It is a coterminal angle with 30 degrees. So these angles end up in the same place, but you spin around a different number of rotations. Okay, we're going to take a pause. Okay, we're going to sketch the angle 135 degrees. So 135 degrees is, well, if I set up a coordinate plane and put my initial side on the positive x-axis, the angle is positive, so the terminal side is going to open counterclockwise. And every quarter of the coordinate plane, we add another 90 degrees. So the positive y-axis is 90 degrees. The negative x-axis would be 180 degrees. The negative y-axis would be 270. And then one rotation would be 360 degrees. So 135 degrees is halfway between between 90 and 180. So the terminal side would go right here, halfway between 180 and 90 degrees. So I'm going to just label this. It opens up in the positive direction. So theta is equal to 135 degrees. You can call the angle anything you want. You can call it A, B, C, D, E. You can call it theta. You can call it epsilon, whatever you want. Okay. All right. So negative 180 degrees. The angle starts on the x-axis, positive x-axis, and since the angle is negative, it's going to swing open in the clockwise direction. And 180 degrees would be half of the circle. So the terminal side is gonna end up on the negative x-axis. So we end up with, let's just call our angle A this time is equal to negative 180 degrees. You might notice that the initial side and the terminal side also have a coterminal angle of positive 180 degrees, because if I spin in the positive direction, So counterclockwise, I'm going to just spin 180 degrees, and I have the same terminal and initial side. Okay, so 390 degrees. Wow, let's do a different one. Let's do 450 degrees. Okay, so I'm going to end up with, I'm going to start with my terminal side, or my initial side, on the positive x-axis, and then I'm going to start rotating. So I'm going to go around one full circle, 180 degrees. Oh, wait, sorry, a full circle, 360 degrees. And then, so I can see that 450 is split up into 360 plus 90 degrees. So after I spin one full rotation, I need to spin another quarter rotation to 90 degrees. So my initial side is on the positive x-axis, and then my terminal side is going to be on the positive y-axis. So the angle here, I'm going to mark it as like this really curly one full rotation plus a little bit more. So theta is equal to 450 degrees. Coterminal angle of 90 degrees. All right, so we're going to sketch a couple angles in radians, and we're going to do a lot of practice with this in class. All right. So like I told you before, really briefly actually, that one full rotation around the coordinate plane is equal to 2 pi. So if I go around one full rotation, that would end up being 2 pi. If I go half a rotation, well, half of 2 pi would be pi. Half of pi would be pi, half pi. So this is 3/4 pi, or 1.5 pi. So now the next thing to do is, when I look at my angle in radians, what I'm looking at is how to break up the circle. So I'm breaking up the circle into thirds, but it's, remember how many pi's are there in the full circle? There's 2. So in the top of the top half in 1 pi right here, I need to split up my, I'm just going to draw a circle, my circle into 3 sections. So I'm going to, this 180 degrees, I'm going to split up into 60-degree wedges. So I have section 1, section 2, and section 3. And then for the second half of the circle, I'm going to have another section. So 4, 5, and 6. So if I go all the way around the circle, that would be 6 pi over 3, which is equal to 2 pi. Okay. So the bottom number tells me how many sections to split up half the circle into, or if you look at the bottom number, just double the number, and that's how many sections you split the whole circle up into. Okay, so now I need to sketch my angle. The top number tells me how many wedges I count. So I'm going to count 1 wedge plus another wedge plus 3 plus 4. So the angle is going to be graphed from the positive x-axis to the terminal side between wedges 4 and 5. So cleaning this up a little, my angle would look like this. I have 1, 2, 3, 4, 5. Okay, so I'm going to open up to the fourth terminal, the fourth wedge. So my angle here would be 4 pi over 3. Okay, is equal to theta. And it's the blue arms. Okay, the next one, 7 pi over 6, tells me, I'm going to give you some tricks to graph these later, but the bottom, remember we look at the bottom number, double the number, so 12. So what I'm going to do is I'm going to make a circle, and I'm going to split my circle up into 12 pieces. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many of those pieces do I count? I count 7 of them. So I'm going to count to, my initial side starts at 0. and I'm going to count 1, 2, 1, 2, 3, 4, 5, 6, 7. So my terminal side is 1/6 past pi. Okay, so from here to here, that is theta is equal to 7 pi over 6. And we measure that angle by the arc length. This arc length has an arc length of 7 pi over 6 radians. Okay, negative 3 pi. So opening in the negative direction, start with a circle. And this time, since this is negative 3 pi over 1, I only need to split this circle into 2 parts because remember, you double the number. So I only have to split it into 2 wedges, whoosh, straight across like that. Okay, so what I'm going to do is start with my positive x-axis, my initial side, and then I need to start counting. So I need to count three rotations here. So I go to the green line, that's 1, 2, 3. So negative 3 pi would end up on would just be 180 degrees. It's the same thing as 180 degrees, or pi, or negative 3 pi, or 3 pi. They're all the same. Okay, we're going to do a lot more practice with this in class.